Hello again, YouTube. This is Josh Feinstein. You're watching Code Everest, and welcome to Enigma Machine Part 2. In Part 1, I explained what the Enigma Machine was and how it works. In the description to that video is a great YouTube video showing the Enigma Machine and all the moving parts. This is Part 2, where I'm going to continue coding it and getting it to do its complex machinations and features. So let's jump right in. We've got our wire pairs, which are the mutations of switching pairs of 20 letters of the alphabet. And then we've got our spindles, which have a set of, kind of like a cipher where 1 is 20, in this case 21, 2 is 12, 3 is 6. Those correspond to letters. So A is then the 21st letter of the alphabet. 3 consecutive spindles. The first thing I'm going to do is get it to work in a specific order. I kind of understand how I'm going to try to do it. The next thing would be to set the configuration so that the order of the spindles can change. So first things first, we've got this function. It takes our message, and then it's got these other things that I set up, but we haven't used them just yet. So the first thing is the spindle offset. If you imagine each spindle as a rotating gear with 26 letters on it, in our case it's going to be numbers that will correspond to letters. You've got your 3 in a row. Let's say they all started 0, so you've got A, A, A. The Enigma Machine was designed so that you could change it, thereby increasing its complexity. So you could have this one starting at G, and this one starting at T, and this one starting at A, or whatever. So in the case of our offsets, let's just assume, if no one puts anything into our function here, I'm going to get rid of this configuration for now. Let's say the offset is at 0. Now, the first gear would click with each character, and then once it reached 26, the second gear would click once. So the rotation point 1, the point at which gear 2 would click, would be at 26. Now, that was also configurable on the Enigma Machine, further increasing its complexity. So let's say our default value is 26 if no one enters that into the algorithm. So when you do run this, you can really complicate matters. So let's just say everything's, gear 2 and 3 will change at 26, and, rotation point 2, and our offsets are going to start at 0. So we're going to need in our function some counters. So what should I call these? Let's say we'll let spindle 1 counter. We're going to start that at 0. Well, no, that's going to start at our spindle 1 offset. Right. And we're going to do that for all 3. So when we initialize our function, at least in the basic case, spindles 1, 2, and 3's counter will start at what their offset. Do I want to do it that way? I might. My brain's got multiple ideas floating around. I think that's what I want to do for now. Yeah, so they're going to start at 0. So our message comes in. It gets split into the set of numbers based on our wire pairs. So like the Enigma Machine, this wire pair, this is going to exist on this page, this enigmamachine.js file. And anytime you start your Enigma Machine, you were able to move those wires around. The spindles didn't change, but the wires could. So this object here can change before you run the function anytime you want to run it. These other spindles I'm going to move to a separate spindles.js file later. They're here now because I find it much easier to debug when I can just scroll up and look at them. So those spindles, these numbers wouldn't change. Every Enigma Machine spindle was manufactured to be the same. So those won't change. So we have our thing split into elements. So now what's going to happen? I initially have this set up as a map. So we're just going through the array, changing them, going through the array, changing them, going through the array, and changing them 3 times for 3 spindles. That's not how the Enigma Machine worked. In the actual Enigma Machine, the first letter goes in to spindle 1, then spindle 1 cranks, goes into 2, and then 3. Then the next one goes in, then the spindle cranks, etc. So each time, I think what I have to do is nest these functions. So each time it goes through, we need to increment the offset. And what that's going to do is basically, our counter, the offsets are starting position 0. So A is whatever, 1 is whatever. the counter is at 0. So each time it increases, we're going to do that element plus that offset. So that's why I'm a little bit unsure about lines 128 through 130. Counter, offset, these are all things I made up, and they're going to get confusing, and I don't want them to be too confusing. So the first thing, let's just start coding and see what makes the most sense as I'm going. So messageArray.map is going to take the first element, which is the letter H, number, and then I want it to how do I want to do this? Yeah, this is what I want to do. Oh, sorry, so let's say in the simplest case, one letter, H, it's going to come in with its coded pair, which happens here. Then it's going to go into spindle 1. So that's the current element of spindle 1. That's the number that we're going to pass to spindle 2. How do I want to do this? All right, watch this. Spindle 2 is going to get passed at the element plus spindle offset. I don't know if I need this counter. I think I might just use the offset. That's what I'm trying to figure out here. But I think I need to set it to a variable so that I can increment it, because if I just use the argument is static. So the spindle counter is 0 because the spindle offset is 0. So the first time we go into our function, let's start with letter A, start at the very beginning. A comes in, it goes into spindle 1 at the number that it is, which is 1, plus the counter, which is 0. So 1 plus 0 is 1, so it's at 1, and then that goes into spindle 2. And now, where it gets really complicated to look at, which is why I'm going to, oops, this is the wrong character. I'm going to put it like this. So now that's all going to be in the object spindle 3. So let's break this down, some indentation to make it clearer. What? Oh, my prettier wants to put it all in one line. That's okay for now. So that's going to go into the spindle counter, then it's going to go into spindle counter whatever, but then this is going to be plus the spindle 2 counter, and then this entire thing is going to be offset by the spindle 3 counter. And remember, spindle. Remember that the very first time, oh, this is spindle 1 counter. The very first time, oh, I keep misspelling things. All right, the very first time this happens, these are all 0. The spindle 1 counter is going to increment by 1 every single time this runs. So after it goes through the first element in the array, we're going to do, I keep writing spindle. Spindle 1 counter plus plus, which will add 1 to it. Now, if spindle counter 1 is equal to, oh sorry, spindle 1 counter is equal to rotate point 1. Now remember, that's 26. That means if we're starting at 0, if the spindle clicks around and then happens to get to 26, we've made 1 revolution. That means our spindle 2 counter needs to get incremented by 1. And it's white. Why is this white? Spindle counter, spindle 2 counter? Yeah, I don't know why it's white. There must be some kind of a error going on. Or my linter's freaking out. All right, now if spindle 2 counter is equal to rotate point 2, which is at its basic case 26, that means spindle 3 counter plus plus. Maybe I should just do plus 1 equals counter plus 1. For some reason my linter likes that better. I want to introduce, so one thing that's going to happen is spindle 1 is going to have to flip around, you know, once it gets to 27, like at 26 it should be 0 again at 27, so everything should be modulus 27, because I don't want it to go to 52, I want it to reset. So 27 is 0 again, and then 52 is 26. Would that be modulus 26? I believe that's modulus 26. Let's do I like to second guess myself, because usually, it's funny, a lot of times in my previous video for number counter, number translator, I was so sure that I didn't make any mistakes that I was questioning the basic syntax of JavaScript. I actually looked up ampersand ampersand to see if that is the appropriate way to do an and statement in a conditional, because that was more likely that I had forgotten how JavaScript works than that I had mistyped something, which is what actually happened. So rather than decide that I am 100% accurate on what modulus does and how it works, I'm going to just print it out. So we're going to do 27 modulus 26, and that should be 1. What do we get here? Oh, I'm getting all kinds of errors. Let's see, line 140 has an error. So all this gobbledygook is kind of a mess. What did I do? Oh, I see. Wait, what? There's a, okay, maybe putting this in multiple lines was a mistake. Alright, so spindle 2 is going to get spindle 1 plus the spindle 1 counter. Spindle 3 is going to get, yeah, that's what I want. Spindle 1 counter plus 1. There's a mistake here somewhere. Line 79. 79? Oh. Wait a minute. What's the issue here? Oh, I see. No. That's correct. The yellow ones, the pink ones. Where's the issue here? Spindle 3 at... So spindle 1, an element 1 plus the counter, that's a numerical value. That results in a numerical value. Oh. There we go. Yes, let's see if that fixed it. Let's see. No, still looks like a problem. Oh, there's a extra character on line 147. That's for our map. Let me shut this off for a second. I've never tried to nest this object kind of stuff. Yeah, okay, so something seems to be okay. And that's modulus 1. Yeah, 27 is 1. So it's all modulus 26. That answers that modulus question. So 52 should be 0. Right. All right, so let's just check to make sure that line 135 is working as expected. The spindle counters are all 0, and the letter I'm passing in is A. The result we should get is the number 2. So A is 1 in our wire pair. 1 becomes 8. 8 becomes 25. 25 becomes 7. This is not a good thing. So what is the problem? Spindle 1 equals at the element plus spindle counter 1. The current element. Oh, this is from the last video. We don't need to run that anymore. Coded message, yes. Let's save, run it again. we get 7, which is what it was supposed to be, number 7, right here on the third spindle. Cool. So the first time we do that, we want to increment our spindle counter. So if we were to do A twice, like this, we'll get 2 different numbers. Oh, I got an issue already. Spindle 1 counter equals spindle 1 counter plus 1. Oh. Okay. This map function is gonna, it's got an implicit return here that returns this. Let's see. So the code that comes after it is kind of a weird thing. If I were to write return, let's say let answer equal this gobbledygook, and then we're going to increment our thing, then we're going to return the answer. Let's see if that works. It does work. Okay, great. So with arrow functions, you may or may not know, they have implicit returns, and I didn't have a return statement. I believe what was happening was this line was being run, and then I was doing some stuff afterwards. The element was being told to be returned to a thing with a bunch of JavaScript nonsense, and it broke. So let's check it. This is A and A with the spindle counter increasing by 1. So the first time around we get 7 as usual. The second time what happens? A is 1. We go to our spindle, but this is going to be plus 1 because of the counter. So then that's 8. It's going to be 9. That's 20. Then we go to spindle. Wait, what? Did I skip one? 1 is 1. 1 becomes 8. Now we go to spindle. Oh, sorry. 1 is 2. So then, see what I'm saying? It gets complicated. Let me slow down. The spindle 1 counter goes up by 1. So the spindle 1 offset is now, yeah, there. So 1 now becomes 2. So our A is 1. It goes into spindle 1 as 1. Now A is 1 plus the counter, which is 2, so it should be 19. Go into spindle 2 as 19. We get 22. Spindle 3 as 22 is 21. And our answer is 21. Now this is just 2 characters with one thing moving. Now imagine it's 100 characters, one thing's moving, every 26 times that moves, the next one moves, and then every 26 times that moves, the next one moves. This is hard to track. But so far, so good. So now, so if we do plus 1, like this, modulus 26, every time we increment, it should be a multiple of 20. Oh, sorry, it should be less than 26. Still works. So now, let's go back to our conditionals here. Turn these back on. If the spindle 1 counter equals the rotation point. Oh, but wait a second here. Let me check our 26 modulus 26. Is 0. It starts out at 0. I don't want it to increment when it's at 0 on the very first time. So perhaps then we set our spindle 2 and 3 offsets at -1. Because no. That's not going to work. It was 0, and then 1 modulus 26 the second time gives us a 1. So the problem here is I need it to increment when it passes 26 the second time. Not the first time. Sometimes I would use -1 because in this case, spindle 2 counter would want to reset immediately if it starts at -1, but then the code wouldn't work because we would be looking at our element -1. Do we want it to be modulus 27? I had mentioned that earlier. I don't think that's what I want. I mean, if the counter's at 26 and we do modulus 27, I think that is what we want because we've got A through Z. Z is the 26th character. That's not when it resets. So the second A would be the 27th character. It rotates on 26, so then once we get to 26, it adds to that. That becomes 27. If all right, so now it's minus 27. If spindle counter 1 equals rotation point, which is 26, spindle 2 is going to increase, and then that's going to be modulus 27. Then spindle 2 counter, if that equals 26, then this one's going to rotate again, and then this one's going to be modulus 27. I think that's the answer. So now, if we run this, we shouldn't get 7 and 21. We should get 7 and something else. Or did I already increase? Let's do 7. Yeah, no, we tested that. So let's see if we can rotate it 3 times with the same letter. 7, 21, and 8. So I'm going to do my very best not to screw this up. 1 comes in. A comes in. It's a 1. The offset is 0, so it's a 1. We got 8. 8 is 25. 25 is 7. Second time, A, that's a 1. There's an offset. It cranked up. It's a 2. That's 19. 19 goes to spindle 2. 19 is 22. Spindle 3, 22 is 21. To the beginning, A. A is a 1. Now there's a 2. It cranked twice, so now 1 is 3. That's 15. Goes into spindle 2 as 15. 15 is 3. Goes into spindle 3. 3 is 8. And that's our 8. So now, with just a few lines of code here, we have 3 gears that are ratcheting themselves up. I think that's awesome. So what do we want to do next? Let's think here. I could change gears, no pun intended, and set up my configurations. Because remember, this is set with spindle 1, then spindle 2, then spindle 3. But they can be moved, like physically, the Enigma machine allowed you to move them in any order with the same thing where spindle 1 cranks 26 times, but spindle 1 doesn't have to be spindle 1. So I could set that up. Next, the other thing I could do is translate this back into characters so that if you type in AAA, then you get back 3 different letters. That's going to be the final thing that happens, so maybe we'll hold off on that. Let's see if I'm forgetting anything else. The wire pairs. Yeah, I think it's the configurations. So how do we want to set our configurations? One idea I had was to basically call them configuration 1 through 6. And then instead of calling it spindle 1, spindle 2, spindle 3, I could call those variables and then change which one's which based on which configuration is given. And what does that look like? That looks like changing line 136. So the counters are associated with 1, 2, and 3, but what is 1, 2, and 3 will change. And then also this spindle 1 inside spindle 2 inside spindle 3 would also change. Or would it? The numbers 1, 2, and 3 can be the same. I can just change what spindles 1, 2, and 3 mean. So I can call this, that's probably easier. So this is spindle A, This is spindle B. This is spindle C. At this moment, our code does not work. Spindle 1, 2, and 3, offset and rotation points. Spindle 1, 2, and 3 counters, and what's getting past the spindle 1, 2, and 3. These are all hard-coded. I don't want to change the skeletal structure of my code. I just want the function to understand that what it should put into those places in what order will change. So how do I want to do that? Well, to make the function easy to write, now if you look here, we got our spindle offsets and our rotation points. So when you write this function, you could write offset, 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 rotation point, rotation point. So this should still work. Oh, what did I do? Oh, right, spindle 3 is not defined. So now we've got our configurations 1 through 6. So let's write some pseudocode. Configs. And these are ABC. Let's write them as a column. ACB, BAC, BCA, CAB, and CBA. So let's say const config 1, config equals, and then these should all be strings. Oops. Wait, what? So these are our 3 things here. Our second argument here will be our configuration, like before. So now let's say I want to pass into this config 1. Now config 1 is what? Config 1 is just this string. So if we put in config 1, basically, if config 1, spindle A equals spindle 1. So let's say in our function, let spindle 1 equal. Now remember, spindle 1 is what we're passing on line 148. That's where we're actually inserting our numbers into our spindles. So let this equal this. Let spindle 3 equal, and in configuration A, I want this to equal this. Spindle at A, B, and C. So I'm really trying to substitute in these letters. So this is really I don't know if I'm going to be able to call a variable with string manipulation here. But I basically want to insert the letter A here. And I know I know that the character at index 0 here is A. But maybe that's silly. Maybe these should be objects. Let's try this. B, C. And this is spindle A. I hate typing the word spindle. This is spindle B. So setting up these configurations, if you can't already tell, it's going to take a bit of typing. It's not going to be the most fun thing in the world. But if I do that, then spindle 1 is going to be configuration, which is config1. So I'm basically, configuration is going to be passing this object. So it's going to be the configuration right? At A, which is spindle A. Let's do it like this. Let's number these. Spindle A, spindle B, spindle C. So then, well, because that's a number, I think I can just hard code it. I can just do dot notation. So spindle 1, 2, 3. Oh, but configuration is a variable because it's the argument that's getting passed to the function. So I think I do need bracket notation after all. Let's see if this works. If this works, and we're using config1, we should still get our, whatever the answer was earlier. Let's see if, oh, it's gone. But I think it was 721, 14, I think. Let's see what happens. 721.8. Okay, so that seems to have worked. So now all I need to do is code these objects so that they have the right order. So the second configuration is A, C, and then B. The third configuration is B, A, C. The fourth is B, C, A. This is C, A, B, and this is C, B, A. All right, cool. I know, and I've been told over and over, you're supposed to do everything in pseudocode step by step, in order, and then code. And maybe I'll get there with time or what, I don't know. But I find that sometimes I have maybe 70% of it in my head, and it's through the typing that I find the solution. So what we see here, I have 6 configurations, whereas 1, 2, and 3 are the different spindles, A, B, and C, in different orders. And then spindle 1, 2, and 3 here get passed in on line 149. That's the order it's going to get coded. So watch this. If I console log all 6 configurations of spindle, so the first 2 start with spindle A as the first spindle. So the first A that I get back, or sorry, the first number I get in my answer, my coded message, should be 7. But all the they should all be unique. Let's see what we get. Ah, so my first one is not 7. Config 2. Either I wrote this wrong or I'm thinking about it wrong. Config 2. Oh, right, because it goes through spindle C. Of course, none of these are going to be the same. That's the beauty of this Enigma machine, is it's so complicated. Every single piece can change. Every single permutation can change. So the first time it goes in, A is 1. Then it goes directly to spindle C. 1 becomes 21. And then it goes into spindle B. Oh, wait. It's 1, goes spindle A. Yeah, that's 8. Then it goes to spindle C as 8. That's 20. Then it goes in spindle B as 20. And I get 23 right here. 23. Yeah. All right. So this Enigma machine is actually really coming together. Yeah, I think that's it. Yeah, all the spindle counters count. The spindle 1 counter counts every time. The spindle 2 counter only counts. Oh, these parentheses are all wrong. Whoops, whoops, whoops. Come here. All right. But while I did get lost in the sauce for a second there because I realized I had a typo, what I'm saying still holds, and that is that my spindle 2 counter counts only when spindle 1 counter is at 26. My spindle 3 counter only counts when my spindle 2 counter is at 26, starting at 0. Now let's talk about these offsets and the rotation points. Now I can set up spindle 1 to start with an offset of 2, so that if it receives a 1, it's going to think it's a 3. And I can set spindle 2 to start at 24, so that if it receives a 2, it's going to be at 26, or Z. And I can set this one to 9. And now I can edit my rotation points, which means that when spindle, for example here, if spindle 1 counter equals rotation point, let's say if it equals 15, that's when I'm going to increment my spindle 2 counter. And I'm going to increment this one when it reaches 1. So let's see if nothing broke and I still get numbers. Here we go. I got an undefined. And I'm only getting 3 answers, which is strange. Am I nuts or did I get 6 earlier? Oh, there's no C here in counter. That's an issue. Now I'm only getting 2 responses. All right, so there's a problem here, but that is the idea. So let's try and figure, let me go back and let's try and figure out why I got that error. But let's just see if, yeah, my configurations are working. These offsets are pretty interesting. So let's start with the offsets. Let me just offset everything by 1 and see, and let me turn all these configs. All the configs work. I can't see why that would cause an issue. It's just a reordering of our inputs. So these offsets work. That's an offset of 0. Yeah, okay. I think the problem was when I changed this. Let's change those to 15s. What did I put here? I put a 26. Why did I get an undefined? This was 24. Oh, I think I know. This was 24. And then because we're passing it 3-letter A's, that means that the spindle 1 is going to rotate 3 times, increment 3 times. Or let's start this. So it's going to become 25, then it's going to become 26, and then it should go back to 0. So let's see if that's what caused the issue. Okay. So there's an issue with this modulus mumbo jumbo here. Modulus 27. So what happens? It's 24. If you notice, it worked exactly 3 times. If I add a 4th A, I should get 2 undefineds in the end. No, I get a 7. Huh, that's okay. So the first time our that's so interesting. Our 1 offset is 24. Wait, no, that doesn't make sense. That's the offset. I think the issues at our rotations? No, that doesn't make sense either. If I put these all back at 26s. I think maybe that was the issues, that I was thinking about this whole modulus thing all wrong. Let's say the rotation point here is 25 and this is 24. So that should rotate right away. Right, and then if this is modulus 27, yeah, the issue is this modulus mumbo jumbo. But I'm just thinking, that means that the very first time we run this function, spindle counter, oh no. All right, so if the spindle counter is 26, rotation point is 26, then it's going to add 1 modulus 26. Which means if the spindle counter is at 25, then we add 1, it's 26, it's going to go right to 0. Maybe that's not what I want. So let's just put a whole bunch of letters in here. Let's get this thing cranking out. Why can't I see this whole array? Show me this whole array. Never seen this in VS Code. But what we can do instead What we can do instead is just console log our spindle counters. Console.log spindle counter, spindle counter 2. So let's log spindle counter 2. Should never log. Spindle counter, oh, spindle 2 counter. It shouldn't log because it doesn't reach 26. Or does it? Oh no, because we started 24, it should. Spindle 2 counter is not defined. What am I doing wrong? Spindle 2 counter. Not defined. Let's go back to our 26. What? Spindle. Really? So it starts at 1. Let's console log it before and after. Each iteration should be 0 and then 1. And then outside of that if statement, 0, 1, and 1. So the first time it goes in, it's 24. Spindle counter 2 is 0. Then it's 25. Oh, what? Spindle 1 counter. 25, then 0. Yeah, it goes right to 0, and we need it to have a 26. That's why I did modules 27 to start with. So what's the issue? 25, 26, 0. That's what I want. And then now the spindle 2 counter should be 0. Oh, let me make this a better log. This is the spindle 2. So the spindle 2 counter is 1. And then it's 1. And then it's 1. It should start at 0. Why is it starting at 1? Spindle 2 counter equals spindle 2 offset. Spindle 2 offset is 0. So it looks to me... Oh, because our the rotation point was set to 25 because of an earlier test that I forgot to correct for. Yes, 0, 1, and 1. That's exactly what I want to see. So now let's set the spindle... So let's say we've got A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. The rotation point for spindle 3... Actually, wait, I'm so dumb. Let's just do this. Oh, I said dumb again. I got to stop being so negative. I made a mistake, which is fine. Let's set the spindle 2 counter to 25. So we're going to do first letter, it's going to go to 25. Next letter is 26. Spindle 3 counter goes up to 26. And then the spindle 3 counter should go up to 1. So we should see spindle 1 counter 25, 26, 0. Spindle 2 should be 0, 1, 1. Spindle 3 should be 0, 0, 1. And if that works, then I believe we've done it. Spindle 3 counter, spindle 3 counter. So we got 25, 25. Oh, well, I said that wrong, but it starts 25, and then the spindle 3 counter 0. Next time it's 26, so spindle 2 goes up, that's 26. Spindle 3 counter now is at 1. Now spindle 1 counter goes to 0, spindle 2 counter goes to 26, and now the spindle 3 counter is at 2. Oh, there's the issue. There's an issue. Okay, Spindle 1 is only at 26 once because it clicks every single time. Once spindle 2 reaches 26, every single time we're passing a letter through, it will be 26 until spindle counter 1 reaches 26 again, which means spindle 3 is going to increment every single time for that set of 26. We need to set this up so that it only increments spindle counter 3 as spindle counter 2 becomes 26 the first time, and not every single time after that. Which would be if we only check to increment spindle counter 2 if spindle counter 2 is currently 25. If spindle wait, no. I'm close. I'm close. If spindle counter 2 is 25 and then becomes 26, we want to increment spindle counter 3. If it's already 26, we don't. So this on line 160, it says if spindle counter 2 is equal to rotation point 2. If it is 26, then do that. But I can do a nested if statement, but I'm thinking it's really only in the case that spindle counter 2 is 25. So what if we did something like this? If, whoa, easy there, buddy. If spindle 2 counter is equal to 25. We take all this goodness from here and stick it in there. So this is what runs if spindle counter 2 is 25. It does that. This is kind of a, in a way, a sort of a base case. So if it's 25, run all the code that we had previously. Don't forget this. Right. Else, so if you look at this, if spindle counter is 25, spindle counter 1 increment by 1. Now if spindle counter 1 is equal to the rotation point, increment spindle counter 2 by 1, which is now 26, which means the next time this code block runs at 26, this entire code block will not run. But at that point, it becomes 26, it's still running. So now spindle count 2, if that's equal to 26, which it now is on the time that it becomes 26, increment spindle counter 3. Other than that, i.e. else, increment spindle counter 1, and then when it reaches rotation point, increment spindle counter 2, which means it's only going to run the other stuff in that one case. And then we can put all our console logs back in. This is cool. Let's see if it works. So now if we run this, if I did everything right, hopefully it won't break. So now what do we have? Immediately our spindle counter increases 25. Spindle counter 2 is 25. Spindle counter 3 is 0. Next, spindle counter 1 becomes 26, which increments spindle counter 2, which is 26. Then spindle counter, oh, I didn't log spindle counter 3 there. Where's 3? 3. Oh, I've got way too much code. This is not necessary anymore. So now we've got, if it's 25, increment 1, and then if it's a rotation, increment 2. If it's the rotation point, increment 3, else increment 1 and 2. Let's rerun this. I thought I saw more console logs than I wanted to see. All right, so now it's 25. Let's look at our function here. It starts at 24, 1 increments to 25. 22 remains 25, 3 remains 0. Now 1 becomes 26, which means 2 becomes 26, which means 3 becomes 1. Now 1, it goes back to 0, 2 remains at 26, 3 remains at 1. Boom. That was cool. Okay, that's super cool. So that solved that. The counters reset as they should. But we're getting undefined. I think I know why. I think I just figured out why. We're getting undefined now because we're doing our element plus spindle counters, and at that point they're above 26. They're too high. There's no matching key value pair in our object to handle that number because I didn't modulus 27 them. Which sounds to me like a quick fix. So we'll put these in brackets, and we're going to do modulus 27 there. And then we're going to take that whole thing. Wait, spindle 1, blah, blah, blah. And then that's a spindle 2. So now this whole thing is going to go inside here. And that's going to be modulus 27. That was the issue. Please work. Oh, it worked. It worked. I have an Enigma machine. So let's just put in a bunch of characters. We should get a whole array of numbers. Oh no, come on. What happened here? Oh, so close. Let's get rid of all these logs here. So close. What happened? Spindle 3. I think this is too hard to read as a human. So input, we'll call this input for spindle 2. And that equals that. Input for spindle 3. So now our answer equals no, we don't need this. So now answer equals spindle 3 input for spindle 2 modulus 27 plus spindle. Wait, what? Am I nuts here? What did I do? I shouldn't have erased the last piece because I threw myself off. Okay. Put that back. Let input for spindle 1 equals the element plus counter spindle, yeah, spindle counter, spindle 1, spindle 1 counter modulus 27. And now our input for spindle 2 is going to be spindle 1 at the input for spindle 1 plus the spindle 2 counter modulus 27. Now the input, and now the answer becomes, this is a mess. Now the answer becomes, let answer become, no, input for spindle 3 becomes spindle 2, the input for spindle 2 plus the spindle 3 counter modulus 27. And then the answer, spindle 3 at the input for spindle 3 plus, the spindle, yeah, fingers crossed. Input for spindle 2 is not defined. Input for spindle 2. Input for spindle 2. What? Let's look at this a little closer. Line 150. Oh. I believe it was 721.8 at the regular old inputs. 721.8. Okay, so right now this is getting closer, but I still got undefined. Oh, there's no parentheses here. Why does Prettier keep doing that? Oops, that looks a little silly, but so let's go back. This is 24. This is 25. And let's run it. Undefined. Undefined. Also, there's another issue. Shouldn't we be getting 721.8? Oh no, because I moved these. Something must be happening here. Let's console log the spindle 3 counter. Spin 3, spindle 3 counter. And that we need it here and here. And we should see 3 numbers, 0, 0, and 1, I believe. 0, 1, and 1. This becomes 25, then it becomes 26, and this becomes 20. Yeah, okay. This is 23. It should be 0, 0, and 1. And let me add some more numbers here. That's 0, 0, 1, 1, 1. That should be 0, 0, 0, 1, 1. Yep. So far, so good. Now let's do 1, 2, and 3. Just to make sure there's nothing wrong with our spindle counters. Ah. 1, 2. Oh. 1 and 2. Right. 23, 25, 0, 24, 25, 0, 25, 25, 0, 26, 26, 1, 0, 26, 1. Let's add some more letters here. 0, 26, 1, 1, 26, 1, 2, 26, 1, 1, 3, 26, 1. Yeah, our spindle counters are working just fine. So that is good news. So the real question is, why are we getting undefined? Why are we getting undefined? Let's walk through. I'm going to pause for now. I'll think this through because this video is probably going to get boring if I don't. Hello again, YouTube. So it turns out part 2 of Enigma Machine has been an hour long. So I am going to call this the end of part 2. Gotten quite far. We've got our 3 spindles. Our spindles are counting consecutively. And we're able to enter configurations, all 6 permutations of the order of the spindles. That's pretty awesome. I'm pretty happy with that. I'm not happy with this undefined error. I believe it has to do with the way we're calling our objects to see what the next values are with this modulus 27 thing. I think at a certain point, maybe, I'm not quite sure what it is, but I'm going to look into this on my own a little bit, try to think about it, take a break, maybe have a snack, and not beat myself up because I've done it myself, and a lot of my friends you know, get so caught up in an issue that they just end up beating themselves up, and that doesn't help anything. So I'm just gonna relax, maybe watch a little TV, think some more. One of the mentors that I have has often told me that most of their time is not spent coding, but it's spent thinking. So I'm gonna do that, just that. I'm going to think. So thank you for watching. Please subscribe to Code Everest. I really like making these videos. I really hope you enjoy watching them. This Enigma Machine project is pretty cool. And yeah, that's it. Stay tuned for more videos. This is Josh Feinstein from Code Everest, signing out.